Welcome to the show where I help people better understand supply chain management. Today we're learning about simple forecasting methods. Simple forecasting methods in supply chain management are straightforward, less complex techniques to predict future demand, inventory needs, and other supply chain activities. These methods rely on basic mathematical calculations and assumptions, making them easier to implement and understand, especially for small businesses or situations where the complexity of the data does not justify the use of more sophisticated models, which I'll be talking about over the next couple of days. But back to simple forecasting methods for now. Despite their simplicity, these methods can still provide valuable insights for decision making. So let's delve into some of these methods and provide examples for each. First, there's the naive forecasting. Naive forecasting involves using the most recent period's data as a forecast for the next period. This method assumes that what happened most recently will continue to happen in the near future, making it a good choice when demand is relatively stable and does not show any significant trends or seasonality. For example, a local cafe might use last week's coffee bean consumption to order beans for the current week, assuming similar customer traffic. There's a simple moving average. The estimate averages a fixed number of the most recent actual data points to generate a forecast. By smoothing out short-term fluctuations, this method can reveal underlying trends in the data. The length of the moving average period can be adjusted based on the level of smoothing that's desired. For example, a small retail store averaging sales data from the past 3 months to forecast the next month's sale, hoping to plan inventory levels without getting overwhelmed by weekly sales variability. There are also the weighted moving averages. This method is a variation of the simple moving average where each historical data point is multiplied by a weight before averaging. The weights are assigned based on the relevance of the data, with the more recent data often having more weight under the assumption that it is more indicative of future trends. For example, a boutique clothing store that assigns more weight to the most recent month's sales data when forecasting demand for the next month, reflecting seasonal changes in the fashion trends. There are these simple linear regressions. Simple linear regression predicts a dependent variables, like sales, based on one independent variable, like time. This method assumes a linear relationship between two variables and is used to forecast trends over time. For example, a bookshop might use simple linear regression to forecast sales growth over the next year based on a linear trend observed in monthly sales data over the past 2 years. There are seasonal indexes. While not a forecasting method in itself, seasonal indexes can be applied in conjunction with simple methods to adjust forecasts for seasonal variations. This involves calculating an index for each season or period of time that quantifies how much that period's data deviates from the average. For example, an ice cream truck calculating seasonal indexes based on the historical sales data to adjust naive or moving average forecasts for summer months when sales are typically higher. You might also look at the percentage over the last year. This method forecasts demand based on the percentage change observed in the previous period compared to the same period in the preceding year. It's particularly useful for businesses with seasonal products or services. For example, a gardening supply store forecasting this year's spring sales based on last year's spring sales increased by the percentage growth rate observed from the previous year to the year before that. So 2 years from the present day. There's also the exponential smoothing. While there are more complex versions, simple exponential smoothing involves applying a smoothing constant to the most recent period's actuals and the most recent forecast, effectively giving more weight to recent observations. This method can be particularly useful when there is no clear trend or seasonal pattern in the data. For example, a software company using simple exponential smoothing to forecast monthly user subscriptions, adjusting the smoothing constant to give more relevance to the most recent month's growth rates. These simple forecasting methods offer a balance between ease of use and the ability to make reasonably accurate predictions. Choosing the right method depends on the specific characteristics of the demand pattern, the available historical data, and the level of detail required for the forecast.